Hi, good morning. I'm Oliver Gao. I'm the director of Cornell System Engineering Program here. I have been privileged to conduct this what I call the systems conversations with our distinguished speakers that we bring to Cornell. So today, I'm very delighted and honored to introduce to you Professor Avigdor Gao. Avigdor, and he is actually the Benjamin and Florence Free Chaired Professor of Data Science at the Technion, Israel Institute of Technology, which is world-renowned research as well as education institution. So actually, he is the head of the Big Data Integration Laboratory, and also he has been doing a lot of wonderful work in data ecosystems, which is really representing the frontier of what nowadays people call, the new oil for the new era. Right, so now if I can call Avi, welcome to Cornell. It's great. It's really great to have you here. Before we dive into more closely into your research areas, and I believe all of us, including our audience, would definitely like to learn more about you and your research, your interest, and also your career, whatever you would like to share with us.
Thank you. So it's great being here. Thank you for inviting me both for the talk and for this discussion. I'm indeed a professor at the Technion. Currently, I reside for a few months on Roosevelt Island in New York City as part of the Cornell Tech campus.
Mm-hmm. And which is actually a collaboration between Cornell and the Technion.
Exactly. Yes. Yes. So my work currently can be put in the field of data science. My research career started as a database researcher, and this is where I still find my roots. And in particular, I perform research in data integration, which is basically how to let different data sets be connected together. Different techniques, it changed over time. It started as heuristics, a little bit more of the theoretical work. Now, to be honest, being pushed by my students, we do a lot of work in machine learning and deep learning as well, all in the context of data integration. I have been a professor at the Technion for more than 20 years now. Before that, I was a professor for a few years at Rutgers University in New Jersey, and before that I did my postdoc at the University of Toronto. My career started at the Technion as a PhD student, and it was great to come back to the same department where I started at the beginning. Actually, our department is not very different from the systems center that you had mentioned. It started as a department for industrial engineering and management, where industrial engineering is basically about what connects systems together. So we do have also part of our education curriculum this element. In recent years, we have delved more into data science. And now the majority of the department, both in research and in education, is devoted to data science. We do have an undergrad in data science and a graduate program in data science, and that's an opportunity to get very good students to do research with me.
Wonderful. Thank you, Avi. It's kind of, when you talk about this, and also thank you for sharing your career, past, what you did before with us. So, you talk about kind of briefly the development of computer science and then the data science, and of course you mentioned machine learning. So I know that now all over the world there are so many people and so many education institutions who are starting this data science program. I think it's a very nice thing, right? It's a very nice thing. It exemplifies the importance of data. But in the meantime, I also see that for the general public, data science, while it's everywhere, it could be, misunderstood. So, would you mind giving us, a brief sense about what now, from your expertise perspective, what do we mean by data science, and why? So, for example, computer science, computers have been with us for decades, and why, in this past, say, couple I would say, or 1 decade. And this data science is gaining, from big data and the data science gaining such momentum. So we want to have a better understanding of what data science is and why it's going to be so important.
So to start with, the data science is still a concept that is deliberated, and people may have different approaches to it. We had to think about it when we were building our own education program of what is data science. Mm-hmm. Is it really statistics? Is it computer science? Is it a whole new area of research, and so on? And you hit right on the point when you said that it happened within a decade. So it happened so fast in terms of academic education and institutions. This is like a minuscule point in time. And the question, is this here to last? And this is another good question. Mm-hmm. We believe it is. Now, there were few of these technologies that came into being around the same time, and they were mature enough to allow this data science to progress. And to understand that, we need to understand what's a data science, what's a data life cycle. So what happens in data in projects? So you start by gathering in data, and then you need to manage them somewhere. You perform analytics on them, and then you present results or some understandings of the data, and then going back to collecting more data to do the same cycle over and over again. Now, for gathering data, the new technology was very cheap sensors. So sensors became prominent everywhere. In smart cities, you have that in cameras, in telephones, in smartphones. You have lots of sensors that report on your whereabouts and so on. And also humans started putting a lot of information on the web, giving more data to be used and collected. So even if before 10, 15 years as researchers, we used to say, oh, I have this bright idea, but I don't have the data to support it. Now we have more data than we need. We just need to find the right data and work with it. So sensors was one technology. Now, as for storing the data, cloud computing became very prominent, and now we have as much storage as we want to put the data on. Before, even if we had the sensor data, it was very hard to keep it. So we had to look at it and then throw it away. Now we just keep everything. So between the sensors and the cloud, we have a lot of space to have data. With so much data, machine learning technology flourished. So methods that in the 70s were invented, like neural networks, and were not used because they did not produce any results, it turns out that all they needed was just more data. And when they get a lot of data, they can produce the results, which led to the huge advances that we see now in what the public calls AI nowadays. So we talked about sensors, we talked about the cloud computing, we talked about machine learning. And the last component is how you actually present it to people, and that's the visualization. And keep in mind, the screens on phones and monitors in general became much better nowadays. So it's so much easier to present results that, for example, when you think about how to imitate images and figures, things that DALL-E does nowadays and so on, this becomes possible because people can look at it and watch it everywhere. So the combination of these technologies led to a unique situation where we can actually do data projects, which was something that was very hard before. And when we looked at that, we realized that our students, our graduate students, they were doing research, but when they came out to the real world, they worked as data scientists. And the question is, why? And this is a side effect of our program, of our graduate program, because we know how to work with data, we ask our students to do that as well. And as a result, they were trained to work with big data. So we thought about it maybe 6-7 years ago, and we said, wow, if this is something that is just about training, we can give it to our undergrads as well. So we developed a program in data science and engineering where its main axis is the data, which means that throughout the studies, they keep on getting more and more courses that starts with small amounts of data, which is still challenging, but at the end, they have like a capstone project where they are given 600 gigabytes of data. So we thought of giving them teras at the beginning, but we realized that it's difficult enough to work with hundreds of gigabytes. So we give them this data, and by the end of the year, they produce results out of it, after going through all the life cycle processes. And with that came the data science as a program, as a profession, as a research discipline as well.
Wonderful. Thank you, Avi. And I really like, and I think when you first answer my question, actually you already pointed out the keyword life cycle. And also you explained to me, why in the past decade, this data field and came up with the possibility to become a science, right? I think you mentioned like 4 or 5 factors, technology factors, right, that enabled this. So, when we were talking about this, so essentially we can roughly view this data science as another very exciting technology, right? It's really right. It's a technology based, but it can also be very powerful. Right, so in that sense, any technology, right, they become embraced by the society for some good reason. So, for example, it can help us address some of the key challenges. And I think all of us, researchers, we especially I think industrial engineers, right, so or system engineers, you want to use your effort to the most impactful research, right? So to address. So what do you think, in your mind, as some fundamental or key challenges that our society is facing, where you feel data science can be extremely powerful?
Yes. So indeed, when we talk about data science technology, recently we start talking more and more about responsible AI. And I'm going to put that in the context of my own research and also talk about a special education program that we do for responsible AI. So my research, my area of research is data integration. So basically, I take, you can think of that as taking different data sets, integrating them together, and getting more powerful data source to be used. So basically, I can combine data together and then generate new data or new knowledge out of it that was not even planned at the beginning, where somebody was offering me these different pieces of data. So you can think about a situation that I know about where somebody lives from one data set, and I know about their purchase habits from another data set. And then when I combine them together, I find something on these people that I was unable to figure out from doing this or that. Now, this integration is very useful because it offers new horizons and new possibilities to help people. Think about medical applications, where we combine the power of having a lot of people from many countries showing their symptoms and effects and so on. And we've seen that in the pandemic, where when we combine data from multiple sources, we could figure out much faster how to immune the population against COVID. But on the other hand, it can also be disastrous, because when I learn from social media something about political views of people, and then I use that in order to feed them with fake data, that's a bad thing, right? That's an irresponsible. So while the technologies, including the data integration research that I'm working on, is helpful in putting data in a better place to identify new phenomena, it also may cause damage. And that's what we call responsible AI, where you take the technology that could do good and harm as well, and figure out how to make our engineers and our scientists more socially aware. This is nowadays much more important than it used to be before. Before, as a computer scientist, I could have hidden behind the veil saying, I don't know, I just build chips, I just work on computers. I don't know what happens if this will be used as weapons or as cameras for surveillance and so on. I'm just doing my own stuff. But nowadays, the acceptance of AI in the general public is so immediate that any app that you write immediately gets the attention of a lot of people. And people use it without even knowing what will be the risks. So we use social media at a very young age, not understanding that in an older age, somebody will hire, when they're hiring you, they will look at your social media and understand more about you than you are willing to tell in an interview, for example. So how do you become responsible? And together with a team of colleagues, we realized that we cannot use ethics in the philosophical way to educate engineers about responsible AI. Simply because ethics, philosophy will go above their head. We cannot just teach them the law, because the law just puts the borders of where you can act. And within these borders, you may still have gray areas where you need to be able to decide right for wrong for yourself. So what we do need to do is to draw awareness to the problem and do it in a way that will be both fun but also hard. And the way we do that is by combining together groups of data scientists and lawyers, and we put them in the same room together. Well, it's a virtual room because now we do it on Zoom and we do it with multiple universities. For example, we're going to have one such course in the spring where we will have the Technion, Tel Aviv University, Boston University, and Bocconi University in Italy. Mm-hmm. So they meet virtually in mixed groups of data scientists and lawyers, and each meeting, which is 4 hours long, is like an escape room. You are given a problem, and you need skills of both legal and data scientists in order to make it work. We choose applications like autonomous driving, algorithmic job recruitment. We talk about privacy, discrimination. And we put it together in a way that after each class, the students have learned something about ethics, have learned something about talking with different disciplines, and just generate more and more awareness. And the students find it hard. After the first 1 or 2 classes, they feel their contribution is not sufficiently strong. Because it's not like in a math class that if you solve correctly the exercise, you know you did well. Here you speak to another person from a different discipline, and you're not sure whether the message was really accepted as you intended it to be. And they need to explain. For example, data scientists need to explain to lawyers what is fairness using equations. Now, lawyers are not very good at equations. Data scientists may not be very good at explaining it. It turns out fairness in the law is different from fairness in machine learning algorithms. So we put them in these tough spots to work on, and by the end of the course, they really find a lot of strength and courage in these kinds of exercises. And that's how we feel that we can push the responsible AI notion into the world.
Avi, I want to thank you so much for sharing your thoughts. Apparently, your department, your team has chosen a harder path, right? And also, I believe your explanation of data science and the responsible AI, especially data science in the context of responsibility. I think, at least for me, I already know that your program, your vision is very much different from a lot of existing programs. Right. They probably bear the same name, but they're different, right? And as I said, that you have chosen the harder path because you mentioned the the social, the ethics part, right? I think that's really so. Before I dive into other things, I just want to continue this. So we mentioned, you pointed out the power of data science in addressing some of our societal challenges, and also you already kind of when you were talking about that, you already started talking about the pitholes that we could step in. Mm-hmm. So now, so what could be the harmful side for big data and the data science?
So actually the harmful sides can come from multiple directions.
Yes.
The obvious one is the fact that data science can do harm in the world. So surveillance systems, this is one thing. Another thing is that AI may simply take away some of our basic skills as humans. Some of it is already gone. For example, navigation.
Yeah.
Most people navigate with a tool, so when they come to a new place, they don't know where they are in the world and what they do. And this may happen in many different areas as well. For example, using recommendation systems, we are being told where to find the best restaurants, where to find the best movies, where to find the best series. But these are not the best, necessarily best restaurants, absolutely, but rather what are they for you? So by letting the AI choose for me movies, TV series, food, where to go, what to wear, we're becoming less human, right, in terms of our decision-making capabilities. So you can imagine a situation in the future where there will be like parks where people would go and make their own decisions. They will have to drive without a GPS. They will have to decide what to eat, where to eat, what to watch, what to dress. And this will be hard for these people. It may be adventurous, it may be playful, but it will not be what they do on a daily life. So that's one thing that can worry us as humans. There are obvious situations where you got autonomous tools of destruction that can make it much easier to fight. If you think of what happened at the turn of the 20th century, where it was easier to fight because you had like better guns. Now it's easier to fight because you put the human out of the loop. So if all you need to do is to produce more weapons, you don't need to wait until your soldiers grow up, which is a sad story, of course. The third part of danger that I would like to point out may come from the regulation. So it is possible that AI will be conceived to be such a damaging or a damned tool that regulation will try to cripple it in a way that we will not make the full potential out of it. So sometimes it may be, ethical issues. Are we allowed to play God and generate new lives on Earth? Sometimes it may be these weapons of destruction. Sometimes it may be a notion of privacy that may have been good for the 20th century but is no longer valid in the 21st century. So when the regulators put more regulations on AI, it may burden it to the point where people will not be able to innovate. And then we will not be able to seek the full potential of data science.
That seems to be very heavy.
Yes.
So, Avi, as you can see, that as an expert, world-leading expert in this area, of course, you want really, you want to address really at the frontier all those challenges. But we know that people at the frontier, while you're enjoying this excitement of curious discovery, and a lot of times you also have to endure, and also you have to struggle. Especially for you, you look at this. Actually, now from your insights, I realize sciences are not born equal. For example, physical science, physics, or chemistry. These are all sciences. And then you compare to data science. These are totally different. And I think physics or chemistry, it's like, like the one path you mentioned earlier. You just, stay in your room. You figure out how these atoms, how they interact, and you discover all these truths, and you tell the world the truth. But now, data science, it's really from data. Data, actually, essentially, data physical itself, it has no meaning. Mm-hmm. It has no value. But it's really the information. And actually, information is not even the ultimate goal of data science. It's really from the data to information, and then you go to insights.
Right.
And from the insight, and you go to decision making. And then, of course, decision making by individuals expanded to the whole society. That is huge impact. So I can see that's the reason why I asked you about the power, and I asked by the potential danger. Is that my next question? Have you ever at some point struggled in your mind, kind of justifying these two things, or especially when you are in the path-finding stage, mm-hmm. when you are kind of juggling between these two things, good side and the bad side? Have you ever struggled, and what was the outcome from that process? Right. So
when you look at my research, it has a mix of theory and practice. So on the one hand, you identify better algorithms, for example, to integrate data that will maximize its utility and its quality. On the other hand, as you said, data by itself is very hard to justify. You usually put it in a context. So you work, and typically when we work close with industry, we get a lot of these use cases. I worked for many years on smart cities and transportation systems mm-hmm. through European projects. I was involved in the past 3 years in the food technology and food industry using sensor data through some Israeli project. And in all of these places, basically, you discover stuff. And some of the things that you discover may be showing that the system can be more efficient in a way or two. And sometimes you also see that there may be, this efficiency may at the end cause some damage. To be honest, for me, it was never, I was never faced with this. Not because of the applications I was working with. I guess I just didn't happen to hit that specific wall. For example, if I know how to make a better cottage cheese, I don't see what could be the harm to anyone from that. Mm-hmm. Or if I make transportation in a city more efficient. But I don't know, maybe it is part of me as a scientist not getting into a position where I try to answer questions that will cause harm according to my ideology. But I do agree that whenever I talked about responsible AI for undergrad students and people in industry and the high-tech industry and the startup ecosystem, it's also legitimate to have the same line of thinking for scientists as well. Sometimes we do have our regulations. For example, if we deal with human experiments, like the experiment that I'm describing in my talk on data integration, then obviously you need to get an approval from a Helsinki committee. And it is possible that we may need to get to a point that when we do research with data, not just humans, we may have to consider that as an ethical committee to work with. So I guess that for some people, if we work on data for animals, then there might be some harm there as well. And there are works about ethics for working with farm animals, for example, and doing experiments on them and so on. And definitely I see that there may be a point where we have to do that, regulating in a way that will keep our freedom for research, but will set some boundaries about what we cannot cross.
I absolutely agree with you. Avi, it's even though kind of I think any new technology kind of they have good side, they have potential dangerous side. But if you look at human history, right, it's and even if it's interesting. I think back in the summer when we had department chairs and directors retreat actually at the dinner table, and one night, the whole table, all the department chairs, we were spending time talking about, the meaning of human life. Mm-hmm. And some, of course, we talk about DNA, and then somehow people agreed upon that, the meaning of life. It's really kind of course, just physically, we are just a combination of all these different elements, right? Carbon or hydrogen, all these things. But it's really kind of from the, if you really want to find out meaning, it's really about passing on the information. Right, I think that way it's kind of you pass on information, and then you try to discover new intelligence. Mm-hmm. And actually through this process, everything has good side, bad side. But I think that if you look at human history, there is very good reason for us to believe any technology, human beings will be able to harvest it and towards good. So, but I think before we go there, but I feel it kind of your discussion is really helpful. I think for us, for the audience, to really have a very comprehensive view of this data science, and now assume, and I think it's a very good, very safe assumption that human beings will be able to harvest data science. So now we want to go some more technical details. So, and you brought up this, data ecosystems, mm-hmm. And I think so. One thing you talk about life cycle of data, and then you also have this, data ecosystems. And I feel apparently that is really a very nice systems view looking at data science. And please tell us more about your view and also how you define data ecosystem. And somehow I feel, especially with what you have told us, I feel probably ecosystem might be a very good approach for us to harvest data science, but in the meantime prevent, the danger associated.
Right.
Please tell us more about data ecosystems.
Yeah, so the data ecosystem that I refer to is a technical term where basically you have a storage of multiple data sources, where these data sources, as they are being collected, they are being dropped into that ecosystem. Mm-hmm. And when they are needed, they are being retrieved from it. So you can think of it as an extension of a database. The difference between an ecosystem and a database is that when you put data into the database, you already did a lot of pre-processing before that. Mm-hmm. And when you query the database, you have a very specific way of doing it. Now think about taking away these two assumptions. So the data has not been curated before, and the way that you access it may be in many different ways. So all of a sudden, the data needs to behave in a very flexible way. It needs to be collected on the fly, and as soon as and understand what are the user needs when providing the data for them to use. So nowadays, the most common concept that is equivalent to that in industry is called a data lake, where a data lake is basically a place to store data. So you put your data there, it's available using some interface, users can come and take whatever they need. But users usually don't know exactly what they need. They don't know exactly what is the meaning of data. And when we think about a data ecosystem, we can think about an intelligent data lake that makes a lot of decisions automatically for you. For example, as soon as I drop a new data set into the data lake or the data ecosystem, it starts generating links to other data sets. Mm-hmm. And these links are being done through something that we call mappings. And these mappings is an essential part of my research when I do data integration. Now, the side effect of having this generated automatically is a level of uncertainty. So think of an algorithm that is not perfect. So when it says that I'm going to connect these two data sets together through this link, I'm not completely sure that this is the right way of doing it. Okay? So you would say, okay, so we have introduced uncertainty into the system, but my argument is that this uncertainty was always there, only it was shielded because we trusted humans so much to do it for us. So when a DBA said that this field should go here and to do something with it, we accepted it as given. Mm-hmm. In databases, we have the concept of closed world assumption. It basically has two merits to it. One, it says if something is in the database, then it's true. And the other one says that if it's not in the database, it does not exist. And this is what allows us to query a database and ask for a flight from New York to Ithaca. Because we know that if there is a flight, it will be in the database. And we know that if it's not in the database, it does not exist. But obviously, these databases are not completely correct. And nowadays, it becomes even worse because somebody may maliciously put fake data into your database. How do you deal with it? And this is where uncertainty tools come into play. And my research does a lot with probability, different types of uncertainty and probability theories to make sure that when we engage in collaboration with this data, we know what we're getting. We know what will be the quality of our data. Mm-hmm. Sometimes we are willing to accept less reliability in order to get broader perspective. Sometimes we would not like to have data sets that are less reliable in our answers. And in the mix of that, we develop a new theory of how to store data and retrieve data from this data ecosystem, because now it is accompanied with some measure of confidence that can be generated automatically through probabilistic and stochastic models.
Wonderful. So you mentioned the data lake and also the link and also the mapping. It's really, again, it's really kind of to somehow, of course, it's not just simple like quality control or quality insurance. It's really about how you improve the quality of not only the data, but really the insight that you can extract out of the data. Mm-hmm. It sounds to me like there is a need of like a global protocol for data. Do we have anyone? Yes.
So you're talking about a standard.
Yes.
And smart guy used to say that standards are so good because there are so many of them. So we don't have just a single standard. We have multiple standards. And every time we introduce a new standard, we are just stuck with one more standard to map to all other standards. But yes, there are obviously standards to store data. Relational databases have been a very good model for storing data, and despite the fact that people like to criticize relational databases and say we would like a NoSQL database, so a database that does not have the relations restricting us. At the end, and I do this kind of exercise with my students, I give them a NoSQL database to analyze, and the end result is that these databases simply replaced semantics with fast computation. So you can get faster computation, but you understand less about the data that you deal with. And so we need somewhere in between, and the relational database is here as a common standard. So whenever we start talking about data logs or recording data with industry, with other scientists, we always talk about the relational model as a way to think about putting information into the data. So you take different elements of data, and by the fact that you put them on the same row together, mm-hmm. and you give each part of it a name, this is the attribute, immediately you created information out of the data. Mm-hmm. This information may be good, may be bad. When I integrate and I put two rows together and I say this is the same person that I talk about, I also need to say what is my level of confidence in that. But it's a good way of thinking about the data.
Wonderful. So you mentioned these kind of course multiple standards, but can always refer to another one. But you also talk about all these different features or attributes. of this, how we can set up the data. So you mentioned earlier, Avi, you mentioned kind of you did research on how we can either process, store, or actually analyze data depending upon different levels of uncertainty tolerance or uncertainty goals. Mm-hmm. So it's always a trade-off, right? So kind of it's kind of a trade-off between uncertainty and accuracy, right? So with that, and we talk about this, and I was thinking because it would be very dangerous. Actually, it would be very dangerous to have just one standard, or you have like a centralized, like kind of governance of data. So I think I would rather have a distributed, because that way, if one part is messed up, other parts, right? So what's your view about? But however, on the other hand, from quality control point of view, you do want to have some kind of centralized, unified, agreed upon thing. So what's your thinking about the kind of high-level governance versus distributed? What I would say, distributed sustainability, a very broad sense of sustainability. So what's your view about this central versus distributed?
Yeah, so there are two separate topics that I would like to mention here. Yes. So in one of them, I wanted to give to refer to human communication. So there may be regimes under which communication is standardized, in the way that there are some things that you can talk about and some things that you cannot talk about, but when you talk about something, you all know what you're talking about. This is a type of regime that on the one hand will make clear understanding of what is the topic, mm-hmm. but at the same time will prohibit fresh thinking. So within a standard, it's very hard to be flexible. So in that sense, but on the other hand, you don't want to have anarchy, right? Because if you have like a typical Babylon situation or Babel situation where people come and speak different languages, nobody understands each other, this is not good. So it depends on the context. Sometimes it's good to have a centralized standard within maybe an organization, but then when the organization speaks with other organizations, there always needs to be interfaces. And it's very important to have a continuous negotiation. And this is what we have in an ecosystem. It's a continuous negotiation. I keep on improving my links simply by giving it an example to a human and say, do you think this kind of connection together of these two records makes sense? And if they say yes, I'm going to say, okay, now I have a stronger understanding of what's going on. If they say no, same thing. So these negotiations, we need to transfer it into the data ecosystem itself, the negotiation between the different data sets. That's on the one hand. On the other hand, in terms of sustainability, it's always true that having a distributed environment is much better. So in the old days, when a library in Egypt is burned, knowledge of generations is being lost. However, if this data if this knowledge is spread out in different locations, then most likely it will survive, even if some elements of it will be destroyed. So in my class on distributed databases, we talk about the need for replication and what do you replicate and what do you prefer not to replicate for the benefit of performance.
Thank you, Avi. My second to last question, I don't want to pry too much into your upcoming talk, but I cannot help. I think one thing, you talk about, for example, the transparency and the traceability of data, and also I think one key thing is really the matching. I think earlier talking about mapping, right? But it's really I think matching is so critical. Matching is really kind of from system engineering point of view, the objectives or the goals of something versus a form
Mm-hmm.
of a function and a form.
Right.
Right. So this matching, and you mentioned earlier, like the machines are replacing human beings in a lot of things, including the match. However, machines are not necessarily going to be able to do all the things ideally, like humans would do. However, if humans do it, we have human errors, right? So for this kind of this data science, especially in the data ecosystem that you have envisioned, how do you deal with this, human versus machine balancing,
right,
such that jointly they can do a better job?
So it indeed dives deep into my presentation.
Yes.
I will keep one element as a surprise, but
Yes.
I will tell you some of these things.
Thank you.
So basically our starting point is the current state of affairs where algorithms in matching are being used for decision support, having humans making final decisions after them. And humans are perceived to be, when do we need humans? When the decisions are hard, and when we need to verify in general that the machine is working properly. So in our experiments, we actually show that humans are not necessarily better than algorithms in making tough matching decisions. They have biases, and we have identified those biases in one of our papers. And basically, we need to identify whether a human being is making an expert decision making or not. And I'm going to talk about expert decision making in my talk. And then, since we undermine the basic premise of humans controlling algorithms' decisions, the question becomes, how do we actually reshape the place in an order for humans and machines to work jointly, but not in a way that humans just supervise the machines? And this is the part that I'm going to keep as a surprise.
Great. I'll let you keep that. I just distract a little bit because matching is really matching theory has been studied across different disciplines.
Right.
And actually, I have one former PhD student. We worked on some kind of matching. Of course, we just look into that. So, for example, I think there were economists who studied matching, got the Nobel Prize for this matching. Of course, in kind of the traditional matching application, of course, in your context is really matching, kind of the task to probably certain database or this kind of matching. But in the real world, for example, like marriage is matching.
Right.
School choices are matching. All right, even I think for the Nobel Prize winner, he looked at kind of medical school graduate students. After graduate, when they're trying to find their interns, right? They try to use this kind of matching to do the interns. And you just mentioned that based on your simulation study, humans are not necessarily superior than machines in making such kind of matching decisions.
Right.
Just for fun. In that case, and you see that in our world, we see so many tragical marriages. Would you think that someday, if AIs help us, to be matchmakers,
Right.
would we have a better world?
So
this is totally, have nothing to do with this.
No, I mean it can be, it's not necessarily just marriages. It can also be your decisions about where to go to school, what to do in life, and so on. It's true that matching is an essential element in many different disciplines. In machine learning, you can think about classification as a matching problem. And you can also think about the situations of elections as being related to matching and so on.
Many to many, yes.
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 And I guess we're not the first one to think about it. I mean, there is a well-known series on TV that is called Black Mirror, and one of its episodes was exactly about simulating relationship between human beings in order to decide whether this is going to be a good match or not. So we realize, and you don't need my research to know that humans may make bad decisions. We know that. We also know that algorithms are not perfect in their decision making. Each one have its own biases. So algorithms are not sensitive to those psychological effects that humans have. And humans are not hurt by the need to be quantified to a very specific loss function in order to be able to make decisions. So each one of the types, the AI and the humans, may have their own different biases. One thing that I would like to warn from a world where everything is being decided by AI is the lack of freedom. And as a result of that, without having this free spirit to choose or make wrong decisions, you won't necessarily get to some optimal good thing along the way. So you can think about that as humans walk on a plane that needs to be optimized, and as soon as they fall into a local optimum, they will not be able to get out simply because the machines can't get out, and they won't tell them you need to go this way or that way. I see failure in human decisions simply as falling into a local optimum, and humans have the way of jumping out, and we have this algorithmic parallel things to that when we try to use random choices in order to jump out of a local optimum and continue our search. So in that way, I think of bad decisions as part of life, which is something we can improve. If we go back to the restaurant decision making, it's true that if I come for 2 days to Ithaca, I would like to know what are the best places to eat, and not because I simply don't have time to try it out all by myself. But on a general thinking, I would like to diverse my restaurant experience, so maybe I will find something new that I haven't seen before and I would like it. And that means sometimes making the wrong decisions and saying, I should have spent all this money on this restaurant, it's not good enough for me.
Avi, thank you so much. I think you point out that is really a very good warning, because you see that AI, all this machine, if we let them make the decision for us, it means uniform. Mm-hmm. And uniform means lacking of freedom. Right. And the lacking of freedom means lacking of creativity. Mm-hmm. And I think it always is because if we set up the machine and the AI to make the decision for us, we said, okay, they will make decision for us for quote unquote optimal. Right. But the key thing is really how that optimal is defined. How is good or bad defined? Right? It's kind of as if something you think, oh, it was bad, but then sometime later it was good. Right? It's really, I think the key thing is really the freedom. Right? And I think that's so now with all this, actually you already touched upon different aspects, because human society were always evolving, and the reason why we're evolving is because of the future generations. And it's interesting, current generations always think that they're great, and even a lot of times they're complaining that future generations they complain or they're afraid that future generations are not going to be as good as the current generations. But the reality is always future generations are always going to be better than the current. So now my last question is, with all these challenges and also benefits ahead of us in data science, how should we educate our future generations? Within this exciting field that you have been exploring. Right.
So you're right in you made a very nice observation about the fact that we are hurting creativity by striving to optimality. And this is something that we should provide our students the freedom to try, make mistakes, fail, from which they will become only stronger. So I think of university teaching as a continuum to parenting. So
Yeah.
if you're a hovering parent and you make sure your kids make no mistakes, they are just bound to make the mistakes later and fail later. And this is why, for example, we insist on having responsible AI as part of our curriculum, because we don't know how they will fail in the future. So we can't really give them a recipe book of what to do in each possible way, in each possible mistake or decision that they need to make. So we need to give them a broader basis of being able to understand from themselves right from wrong, correct from incorrect, robustness, how to be able to struggle and survive. Because the future work environments will be also completely different from what we knew in the past. They will have to face new challenges in every few years, not just by moving from one company to the other, but having a whole new field of technology open to them. And they need to be able to process all this pretty fast, but also in depth. Because you can process something in a shallow way, and then you're not qualified to deal with it. Or you can take a long time to think about it thoroughly, but then you're not keeping up with the rest of the gang. So basically, processing things fast enough to get the essence and not keep it shallow would be a good way for a person to survive in the world that is facing us in the future.
Beautiful. I really like kind of, you say the college education is like kind of extension of parenting, and I very much agree with you. And even I feel for you and I, we have to agree that even at our age, we feel that we're still growing.
Definitely.
Right. So as a result, I think this reminded me one of the the tip that was given to me by one of my former colleagues when I had my first child, and I asked him, what would you give me as a tip for me to raise a child? And he gave me one word. He said, Oliver, one word is patience. Anyway, but I think it's really kind of because be patient and also especially be tolerant and giving them freedom to make mistakes such that they can really learn the essentials. Right? Instead of they pick up, that teaches me 2 + 2 is equal to 4. Right, and then in the end, sometime later, and they could find, actually, it's not necessary because there is always uncertainty. There is always, the fuzzy age. Avi, it was great to talk to you, and really enlightening to me. Thank you.
Thank you very much. I appreciate the opportunity.
Wonderful. Thank you.